Hello, good evening. Welcome everyone to join GoodWe JA Solar and Antai today webinar about low LCOE and safe solution for utility scale solar in the Philippines. My name is Lý Duy Nguyễn. I will be the host of this webinar, and today I would be very proud to represent our speakers here. I would like to introduce Mr. Leo Zhang, Country Manager of GoodWe in the Philippines, Ms. Yuya Chen, Manager Assistant Application Department of GoodWe, Mr. Ren Gutierrez, Country Manager of the Antai Solar in the Philippines, Ms. Chester Yap, Country Head of JA Solar in the Philippines, Mr. John Wang, Product Marketing Manager of JA Solar, and finally, Mr. Daniel Lee, Sales Director of JA Solar in the Southeast Asia. Welcome everyone, and thank you so much for spending time joining us today in our webinar. As you know, the Philippines market, especially the solar industry in the Philippine market, has been booming for a couple of years now, thanks to the policy of the Philippines government. And today, GoodWe JA Solar and Antai Solar would like to represent to you, would like to share to you our solutions for your solar farm. And starting off, I would like to introduce Mr. Leo Yang, the GoodWe Country Manager of the Philippines, to introduce GoodWe Philippines team, and would like to say greeting to all of the audience here. Hello, Mr. Leo, are you there?
Yeah, hello.
Hello, Mr. Leo.
Yeah. Hello.
Yes.
Can you? Okay. So good afternoon, everyone. So first of all, thank you very much for your time to attending this webinar. And this is Leo, the country manager of GoodWe Philippine market. I'm very great to introduce you about our company to you. So now allow me to start the presentation. So driving the world's smart energy future. This is our company slogan. So our vision is always driving the world's smart energy future, and our mission is to determine to be the main driving force in the global energy transition and create a sustainable future for the Earth, for mankind, and also for the future generations. So during more than 10 years development, so till now we have already installed over 3 million unique solar inverter globally. And the annual power generated is around 56,450 gigawatt hour global. And also we save CO2 annually is around 5,645 million ton. Sorry. Hello. Yeah. So here I would like to briefly introduce our development during these years. We established in from 2010, and our first solar inverters was produced in 2011. Also, our first R&D center was established. And during 2012 and 2013, some of our products like GW4000 and GW70K models got the Fortin AA Award efficiency, top 3 and top 5. And we launched the Asia first energy storage inverter EX series in 2014. At the meantime, we are expanding our global business. We established our UK branch and also Dutch service center. And in 2018, 2015, we officially listed on the NEEQ stock. And also we established our GoodWe Solar Academy. And also our Australia branch was established. And from 2016, we got quite a lot of quality award like TUV rating in 2016. And we also established our another R&D center in Shenzhen. And also we established our European headquarters in Germany in 2018. And in 2020, we officially listed in China Shanghai Stock Exchange. And at the same year, we became the licensing partner of GE. Okay. Next, thank you. Hi, Lizzie. Yeah. So till now, our GoodWe family have over 3,000 employees and more than 600 R&D engineers and more than 100 overseas employees. And in 2021, our revenue is achieved over $420 million US. Yeah, here I would like to sharing the story about being the licensed partner with GE, like comment by the CEO of GE, Tom Buccellato. He explains why GE finally select GoodWe as the licensed partner. That is, means it's not secret that GE is promoting search for quality drive its business and decision process. And behind this license partner history, so more than 32 manufacturers were shortlisted by a group of ethnic researchers and scientists working at GE's research facilities. And they carefully examine and assess everything from technical capability from the key components to firms' financial stability and the extent of global service coverage, also as aesthetic design and brand awareness and the overall reputation. So finally, that is why GE chose GoodWe to be the licensed partners global. Yeah, here is tells you the GoodWe's international business. We have set up more than 30 branches in global, many in West Europe, North America, and Asian Pacific. Okay. And here is our global partners and our global reference projects. Like we are working globally with Granite, Panasonic, and Tata Group, and Marubeni. And we also install quite a lot of big project for the big global brands like Siemens, IKEA, Bosch, Toyota, and Coca-Cola, and so on. And during these 12 years, we also got quite a lot of global awards like Red Dot Design in 2018. Like from 2017 to 2021, we got the EUPD top brands for 5 consecutive years. And also we are the #1 hybrid storage inverter supplier global in 2019. And we are our EH series and our ET series ranking #2 or #5 global. And in 2020, we are the most financially stable inverter companies by Bloomberg NEF. And talking about our production capacity, nowadays, our annual production capacity is around 25 gigawatt for solar inverter and 1 gigawatt hour for battery. Here is our GoodWe HQ. And our global installation is till now is allowed 35 gigawatt, more than 100 countries. And we have been largely used in residential and commercial rooftops and industry and utility scale systems from 0.7 kilowatt to 250 kilowatt. So we got quite a lot of top 1 or top 2 or top 3 in the global rankings. Like we are the top 1 global energy storage supplier. We are ranking top 1 in China, in CZEC, in Korea, and in India. Also, we are top 2 in Australia and top 3 in Spain. And here is our market share. Like in West Europe, we achieve more than 15 or even though to 15 market share in Netherlands or in CZEC. And in Germany, we also allow 10% market share. And in Southeast Asia, like in Vietnam, we allow 7% market share. And here, here is our okay. We also set up quite a lot of overseas warehouse management, like in USA, in Brazil, in UK, in Turkey, in India, in Australia, and then we are also thinking about to have a overseas warehouse in South Asia. Yeah, talking about our service, we are providing our pre-sale service like PV system solution, and also we have PV community. We will provide quite a lot of technical solutions, video guidance, and case studies, and we are also doing quite a lot of GoodWe workshop to share with our customers, to share with the installers, even though the end users. And also we are working with professional after-sale service to ensure the service is qualified, and then to avoid the losses of the installers, of the end users. Sorry, next. Here is our product portfolios. We have residential from 0.7 kilowatt to 15 kilowatt. And for CNI solution, we have 17 kilowatt to 136 kilowatt models. And also we have a big one for utility from like 222 or to 250 kilowatt. Besides, we also have PV and storage solution from 3 kilowatt to 50 kilowatt. Also, we are producing lithium batteries. And now we are also producing the BIPV modulars. Also, we're running our smart energy management system.
Thank you, Mr. Leo, for your presentation.
Okay.
Okay, so before we head into the main part of today is the solution from GoodWe, JA, and Antai. I would like to remind all the guests here that if you have any question, please text us in the Q&A box, and we will answer all of them or some of them in the last Q&A part of this webinar. And for the remaining questions that we cannot answer online, we will answer you via your email you already registered. Thank you very much. And I would like to introduce Mr. Yuel Chen, representative of GoodWe headquarters. She will present in GoodWe solution for utility scale. Hello, Mr. Yuel.
Yes, hello.
Hello. Can you share your screen?
Okay. Today I'm going to present GoodWe utility scale solar plant solution. And in my presentation, there are going to be two parts. The first part is a brief introduction of the construction of utility scale PV plants. And the second part is our solution for utility scale plants. So let's go through the first part. And here we can see the construction cost of the PV plants. We can see in this pie chart, obviously PV module is a big part of this cost. It is important, but we cannot just speculate the importance of it just by the cost of them. For instance, the least part in this pie chart is the design. But this is a really important part. A good design can save a lot of money and work afterward. And could even make more money by reaching a better system efficiency. And this slide shows the construction process of a utility scale PV plant. It includes design, equipment selection, installation, and then the O&M part after they start to operate. In the design process, it needs to be a comprehensive consideration of the whole system. And the equipment selection, we need to consider the safe issue, the reliable issue. So we have to choose the devices who has fully protections. And for the installation, they are standard. So we use the sufficient tools and then following the other standards. And the O&M, there are more things to carry. Maybe you need to do it timely, and we need accuracy. Maybe even we need to respond before the problem even happened. Here shows the necessary steps to build a plant. Here we can see the first one is the material approach. So the approach test is done in this stage. We have to unpack, or we have to unload the materials exactly in the PV area according to the drawings. So that's avoid the second lift or a second shipment in the plant itself on site. And then we have serial constructions, PV bracket installations, electrical equipment installation, cable grounding, commissioning, and connect to the grid. And that's maybe the last step to construct a PV plant. And there are some key points here we need to take care of. And here I just maybe one or two example. For example, the verticality and the levelness of the support installation affects the quality of the entire array, especially the tracking support. The larger installation diversion of the bracket caused the module to crack under force and the brackets to be damaged under wind or snow load. Other thing is that the components handling the installation are not allowed to tremble. Large components to prevent shaking and damage cause cracks and borders. So in these necessary steps, we need to take care of such things I have listed, and much more. And this slide shows the stage of construction. We can see here the main investment period is just 0.5 years. It includes, we choose the location, we do the designing, and then we choose the equipment, and the last one is construction. But the main payback period is over 24 years. And during this period, the only thing we need to do is the O&M. So we can just focus on here, because here is the main payback period. That's when we make money. And I think that's the briefly introduce of the first part. And in the whole, the second part is GoodWe solution for utility scale plants. As we can see in the previous cost pie chart, the inverters may be just a little part of the construction cost, but it's a critical part because it's it will play a role here in the system overview. You will see it converts the DC current to the AC current, and then it overtakes almost all the communication work in the PV area. But here GoodWe provides not only the inverters, we have a full solution. For example, we have this communication box, solar communication box here to the communicating, and then we provide this Emery station in a standard 20-feet container. First of all, I will introduce the HT series 250K inverters. As we can say, we have two types. The first one is 250K and then the 250KN. The main difference is the input current. And we have type 2 SPD integrated and type 1 optional. And the European efficiency is 98.8. And we have IP66 for the protection. We have IV scan, we have FCI, we have two solutions for the PID, which I will mention later. Here, this slide shows the main difference of our two type of GoodWe inverters. We can see we have 250K is compatible with a lot of modules, 182 millimeter modules. They have a maximum current of 14.9, but our inverter here, we can accept maximum DC current is 15 ampere per string. So we have 12 MPPTs, 2 strings per MPPT, and then 24 strings total for the whole inverter. And for 210 millimeter modules, those who has a larger current, so we have 250 KN for this. We can be compatible with maximum DC inputs of 20 ampere. In this case, they have 6 MPPTs and 3 strings per MPPT. That makes it 18 strings per inverter. And since it's more than 2 strings per MPPT, we have the safety issue, and then we considered to not using the fuse, but this smart DC switch instead. And then I will introduce our PID solutions. So the PID of the modules is happening maybe for old stations sometimes, but they can be recovered. For example, we have anti-PID solution is to prevent the PID happening. Here we use the neutral point of the AC side and then a voltage adjustment device to make the voltage between the ground and this neutral point is slightly above 6 volts and half UDC, which is the voltage on the DC side. And this makes the PV negative to the ground is always larger than 6 volts, and that's above 0, and that's how it's preventing this PID happening. Nowadays, the modules they have more modern technology. The PID is not happening anymore, not anymore that much before. So for newly built plants, I think anti-PID function is good. But for some existing plants, maybe it has been operating for over 10 years. We need to maybe do some changes. You want to change the inverter, you need our inverter here, and then we will recommend you to use the PID recovery function. That's to do a reserve reverse voltage between PV negative and PE, and as 600 or 700 volts. And then that's how it do the recovery. So this is for maybe old plants or somewhere. So other than the inverters, we also have this administration solution. So this is the next step of the inverter. It's improve the voltage level. So here we can see it's a standard 20 feet container. So they have the LV side, the ME side, and then the transformer itself. So it's have a large capacity, compact structure. It's really convenient to ship, and also it's reliable operation. And the other thing is it's really easy to install. The administration itself comes in this way. So only LV cables and MA cables needed on site. And this is the single line diagram of our inverters and the MV station, and how the MV station are connecting to each other. So here the inverters connecting to this LV side of the transformer at LV switchgear in the LV room of the MV station, and one inverter will connect to one MCCB, and then that goes to the transformer here, and then goes to the CVC RMU. It's so here it goes connect to the maybe the next MV station, and this arrow goes to the next MV station. So this is where the MV station itself is connecting to themselves. And we also have the PLC solution. The PLC solution is power-like communication. So in this way, we will save a lot of communication lines, cables on site. And our communication box will be hung outside of the administration. And the administration we will power it up. And so since no communication cable needed, so the PLC signals are from the LV side busbar, LV busbar in the administration. And this is our communication box. So this brings us to our another product. The communication box, it can communicate between the inverters and the box, and also between the SCADA system and itself. So that means it can upload all the data from the PV area, and then it can distribute all the commands from the system. For itself, it can connect as a ring connect. All this yellow cable here could be optical fiber, and this purple one here connects to the SCADA system, or we say PPC system. It depends on the distance. If the distance is less than 100 meters, maybe we can use LAN, and otherwise we can use fiber. And with this ring connect, we have an advantage here. Is even though one point in this ring are disconnected, the communication won't just stop, because it can go another way. This is another product of our solution. We have this local SCADA system. It can be on the local side, not connect to the public internet. Also, we can put it in the cloud server. So that means we can put it on online. And this is a briefly introduction of our Solar OS system. We can see the menu here, and then we have intelligent analyzers, we have dispersion rate, and other diagnosis, equipment manage. We can control the equipment, and all the equipment once, or maybe all the equipment in one subarray, and then control them at once. That's all.
Yes, thank you, Ms. Ria, for your presentation. I would like to next introduce our next speaker is Mr. John Wang, the Product Marketing Manager from GoodWe Solar, to introduce their solution for utility. Hello, Mr. John. Hi.
Yeah, hi.
Yes, we can see your full screen. Please start.
Okay. Okay. I will make the presentation on behalf of GoodWe Solar. My topic is GoodWe Solar Deep Blue 3 and 4 X module premium solution for battery LCOE. I will start from four parts. The first part is the design idea of Deep Blue 3. The second is the performance analysis of Deep Blue 3. And the third part is the Deep Blue 4X milestone or PV technology. And the fourth part shall be the project reference. Okay, firstly, let me give a brief introduction of GoodWe Solar. GoodWe Solar was founded in May 2005, and our cumulative shipments have exceeded 95 gigawatts. And our sales covered more than 135 countries and regions, and has 12 global manufacturing bases with global market share over 14%. And we are the number 2 in the global shipments ranking. Okay, let's start from the technical part. The design idea of Deep Blue 3. As we all know, during the past 10 years, the module power output has been increasing very fast. At the year 2009, the typical module power output is about 290 watts, but by the year of 2022, the peak power has already reached 600 watts. Let's review how to approach the module power output. I think mainly from 3 issues. The cell efficiency has increased from 70% in 2009 to above 23.3% in 2022. The second part is mainly about the advanced module encapsulation, such as the application of coating glass, a shaft ribbon, half-cut seal, and some new technologies such as single module paving. The third part is about the big wafer. The wafer size has been continuously increased from 125 millimeter to 182 millimeter. Above all this has contributed to the module power output increasing significantly. Why the module and the wafer size are getting bigger and bigger? I think the main cause is that with bigger module, we can get lower BOS cost. And this chart shows the relationship of the BOS cost and the module. And we can find that when the module power output reaches the 545 watts, the decreasing trend becomes slower and even disappear. It seems that the module size almost hits its upper limitation, and the trend of BOS reduction effect becomes less when keeping in larger wafer size. From another side, let's look at the relationship of the BOS cost and the module efficiency. Yeah, we can easily find that when the module efficiency increases, the BOS cost reduced significantly. It seems that the efficiency contributes more to the BOS cost than the size. And the larger module already reached its bottleneck. The module efficiency increasement will be considered as a priority in the future. So for the module, is the larger the better? We don't think so. The module size sure has its upper limitation. When the module continue to get bigger, we can find that there are no more both saving on system size, but will bring higher risk, such as the mechanical loading risk, transportation difficulty, racking bearing ability, especially in the high wind regions. And in future, improving power through bigger panel shall be valueless. Also, we have done the deformation simulation analysis. We can find that due to the bigger size, the oversized module has more than 20% variation compared with the 182 module under loading test. This means at the high wind area, for oversized module means higher failure risk. From another side, we can find that it's very difficult to carry oversized module by two people, especially dragging on the ground, may lead damage to the solar module. Also, for the installation, one oversized module may require 3 people to work together, and this will bring more dangerous and increase the installation labor cost. Above all, this is the logistic of DeepBlue 3 module design. The size of the solar module is determined by the whole industry chain, including production, installation, transportation, and the solar system configuration. Yeah, the key points shall be the suitable dimension and the electrical property and the premium LCOE. Also, DeepBlue 3 has many product owners. On the left, DeepBlue 3 was awarded with the Energy Yield Simulation Award from TV Reliance, and in the right, after for now is 1 year of field test. DeepBlue 3 module has excellent power yield performance according to the TV now. The second part shall be the performance analysis of DeepBlue 3. Adopted with M10 wafer, we have 3 types of module design, diverse design for the various PV applications. Also, here are the brief core technical features, such as the Persium technology, wafer size upgrades, gallium doped wafer, and 11 bus by technology. And all this bring DeepBlue 3 high reliability and high energy yield. So here are the technical parameters. We can find that with reasonable size and weight, all these advanced mutual technology bring the best LCOE. To verify the energy yield performance, GA Solar cooperates with QE Not, conducting 1-year outdoor solar project monitoring plan at the National PV Center in Tri-City in China. And from the whole year data, we can find that the operating temperature of the 182 millimeter module is lower than that of the 210 module, especially during the high irradiance period. The average module operation temperature gap between the 2 module tests is about 1.5 to 2 degrees, and the maximum gap should be up to 4 to 5 degrees. And as for the power generation, we can find that from the whole year demonstrates the project data, the power generation of the 100 S2 module is about 1.6% higher than large current module. The third part is about DeepBlue 4X, milestone of PV technology. Based on N-type cells, DeepBlue 4X has 3 module tests, a diverse design for both residential and commercial and industrial utility scale projects and applications. And the highest module power is up to 625 watts, and with the module efficiency is up to 22.4%. As for another core technology, is the GE patented Persium cell. Yeah, based on the N-type M10 wafer and using the passivity contact technology. And the minority carrier recombination is suppressed, and with the higher voltage up to 720 microwatts, much higher than the POC. And the cell efficiency could be up to 24.8%. As for the high density encapsulation technology, here shows the J patented GFI technology. GFI is the gapless flexible interconnection with the buffer treatment, optimize the encapsulation material, and could avoid the microcrack issues at the cell interconnection, and higher could boost both higher efficiency and the module power output. And here are the brief highlights or introduction of GoodWe 4X. The Basium cell GFI technology, higher efficiency, lower degradation, and lower temperature coefficiency, higher beneficial benefits, a better lawless performance, excellent reliability. That means better warranty. As for the energy use, according to the whole year's energy use data analysis, the power generation of N-type module is about 3.9% higher than that of P-type module from the whole year data. Okay, as for the first part, let's have a quick review as the product reference. Okay, this is a commercial product with 6.6 megawatts connected at October 2021. And the utility product is 18 megawatts connected in May 2022. And this one is the 55 megawatts connected in Q1 2022 with JD Blue 3 module. And this one is the 132.5 megawatts connected in 2016. Okay, this is all for my presentation. Thank you very much.
Yes, thank you, Mr. John, for your presentation. I would like to introduce the next speaker is Mr. Rain, Country Manager of Antai Solar in the Philippines. Hello, Mr. Rain.
Hi, good afternoon.
Nice to meet you.
Nice to meet you.
Share your screen.
Yeah. Can John exit the share screen so I can share my screen?
Yes, we can see your screen.
Hi, everyone. My name is Ren Gutierrez. I'm from Antai Solar. I'm currently the country manager for the Philippine market. So let me introduce our brand, which is Antai. So about us, we always want to clarify why we use Antai, because I know in the Philippines, Antai means a negative connotation or something like against, but in Chinese, the Antai translation to English is safety and stability. And that's why we want to translate it into our mounting structure or our product. And just to give you a big background of our business, Antai has been growing 30.7% in the last 5 years. We have a 5 gigawatt shipment in 2021. Our revenue last year is $160 million. And we have a 40% average growth in global shipment for the last 3 years. So I know Antai is new in the Philippines, and some of it might hear it just today. But just to give you a background again, we have been in the industry for since 2006, and we have a global layout, and we have a diverse product range. Actually, we already have 6 production bases. Later, I will expound on that. And we have accumulated 19.3 gigawatt of shipment worldwide for the last 15, 16 years already. Like the other colleagues here, we are also #1 in some market. We are ranked 1 in the Japanese market, solar racking market share. We are also #1 in Australia. And we're also #1 in Chile in supplier distribution market. So right now, this is the global layout of Antai. We have been present from Latin America to Europe to Southeast Asia and to Australia. And this is our achievement for the last years. We have a total accumulative shipment 6.2 gigawatt in Japan, 3.9 gigawatt in Australia, 4.6 gigawatt in China, 2.2 gigawatt in Southeast Asia, and we're hoping to add on that, especially in the Philippine market. And we have around 700 megawatt in Latin America and 1.4 gigawatt to the rest of the world. So we want to also to share also to the application for utility scale, or what we can offer for utility scale for Antai. So we have a fixed structure portfolio, but we want to focus right now for this presentation for our ground mount solution. We can cover all scenarios like sloping and complex terrain, coastal areas with high salt, mist, and desert and sandy landform. So here are some of our solutions that we can share for utility scale. We have the concrete foundation solution, or more popularly known here in the Philippines as ballasted type. So we suggest this type of solution for volatile sites like landfills, brownfields, and superfunds, where the soil cannot be penetrated due to potential contamination, or if there's an issue with the soil. This is a cost-effective measure or solution, as this is a pour-in-place solution. We also have the ground screw type, the very popular here in the Philippines, the screw piles. This solution has the high pull-out resistance, very good for clay, gravel, low water table, and dense sand situation. Very cost-effective for large-scale installation for solar farm, but we do not recommend this for smaller ground mount installation. But for larger scale, definitely we would like to recommend if the situation permits. So for Antai, this is our feature. We can have the aluminum, steel, max steel structure with high corrosion resistance. We can do the different design standard to meet the high wind speed and velocity. Right now in the Philippines, we're following the NSCP, or the National Structural Code of the Philippines. And this is also a pre-assembly. We can also do a pre-assembly supporting beam so that you can save time on installation in the site. So here's are the application in open terrain and landfill, and the elevation is customized. We can customize everything for you. Material is anodized aluminum, stainless steel, HDG, and as I've said, max steel structure. Another one is pile ground, or what we call ramming pile or driven pile. This solution is labor cost efficient, for this eliminates additional excavation works. So you don't have to dig or do the excavation. Fit for flat ground, uneven terrain, and different slope condition. So for Antai, we offer flexible adjustment for angles and heights, while during installation, if you need to do some adjustment, we can do it on site. And also we have a pre-assembled beam to save on installation time. The application for this is open terrain. Elevation angle is customized. Foundation is pile in or precast or bore pier. So materials is the same. There's aluminum, stainless steel, and HDG, or hot dip galvanized. So for our racking system, we want to share, especially for the aluminum component of our solution, we want to share what materials we use. For anti-solar, we use the AL6005 T6, or just T6. If you can see, T6 material or T6 aluminum alloy has a superior strength over the commonly used T5 in the industry. So if you can see, the tensile strength is 40 points higher, proof strength is 65 points higher, and the elongation fracture percentage is 3% higher than the normal T5 aluminum structure. So we use this material to ensure, especially for the Philippines, I think in the region in Southeast Asia, we have the highest wind speed velocity. And because of that, we really recommend the higher grade material for the mounting structure, as this will support your solar panel installation for large-scale utility. So we can tailor-made your design. Just we can just you can just submit an SOR to us, or we give you a checklist, and we can do the design for you and wind calculation and everything. So just to share some of our projects, we have the BIPV 12 megawatt in China. We also do rooftop. This is a 50 megawatt project. This one, we're very proud of this installation in Japan. It's a 24 megawatt. If you can see, it's like a roof shape. So the owner challenged our team to maximize the land. So we studied everything and come up with this solution. And we also have the tracker, 2-point solar tracker, single axis. But for the Philippines, we don't recommend this because of the wind speed velocity. The tracker cannot withstand that, but we also have that. We also have the carport. This is one project that we had in the Philippines, Tarlac Medical Center carport, 290 kilowatt. And we also have a 1.67 megawatt rooftop mall in the Philippines. And right now, on our pipeline, I think we had around 85 megawatt worth of installation for this year for the Philippines alone. So anti-solar, unlike other brands or other mounting structure provider, we have our own, as I've said, we have 6 production bases. We have 3 in China, 1 in Turkey, 1 in India, and 1 in Indonesia. And this is our capacity for our delivery, 10 gigawatt for the aluminum racking and 15 gigawatt for the carbon steel solutions. And we also have our own production process. Aside from the certification that we had, we want to make sure that everything goes through the process for QA, quality assurance for our clients. And before that, we have this quality control process. Every single mounting structure or before we ship it to the owner, we make sure that it passed this set of tests, so that we can be at peace with our client that we have provided them the best solution. So this is our the technical standard that we are following. As I've said, we are following the Philippine National Structural Code. And if you can see the basic wind speed of the Philippines, I think from 250. And we designed up to, I think there's one case we designed 310 kilowatt, 310 kph. So it's very high wind speed. So that information is very important for us to ensure the stability of our structure. Once we gather this information, our engineers will design and pick the main items that we can propose to our clients. And of course, we provide structural analysis, wind load analysis, and stress and deflection test for all our structure or all our proposal, especially for large-scale utility projects. And that's all for anti-solar, and we want to help to raise a green role. Thank you, Lizzie. That's all for us.
Yes, thank you, Mr. Ren. Thank you so much for your presentation. I would like to say thank you to all speakers today for your detailed sharing on the solution of utility. And now I would like to direct this subject into the Philippines itself, and would like to learn more insights from the experts that have been working in the Philippine solar industry for years now. As I know, Mr. Ren and Ms. Chester, the representative of Antai Solar and JA Solar, has been working in the Philippines market for quite some time, and they could be the expert that can share with us a little bit more insight of the market, of the policy. And as I have learned in the recent year, the Philippines government has shifted its focus to energy toward the renewable, and they want to turn the whole industry into a greener one. Therefore, many regulation and policy were issued to push the growth of renewable energy faster, and especially solar in this country. So can you help to share more details and insight on that? Maybe we can start with Mr. Rain. Hello, Mr. Rain. Can you share a little bit of insight on this matter?
Yeah, hi, Lizzie. Yes, you're correct. Right now, the Philippines, as you've said earlier, the solar, especially in the utility scale, is booming. But let me share some of my insight. Um, when FIT in the Philippines was consumed or over last 2016, large-scale development for solar slowed down. Um, the market's still there, but it's not as big as before, as during the FIT. But great, we're grateful recently that the DOE and its regulating bodies have intensified the implementation of the Renewable Energy Act of 2008, and the policies inside there and the supporting policies. Later, I want to ask Chester also for her opinion, but one of the policies that I want to share is the renewable portfolio standard, or the RPS, with the aspirational target of 35% of the energy mix should be RE by 2030. This policy um, has required mandated participants to have a 1% incremental increase of their total net energy sales. So imagine from before, from right now, I think very minimal solar um, connected to the grid, but by 2030, it could be as high as 35%. But I also read one article, or I've also read that there is a draft circular from the DOE, that the incremental increase of the RPS from 1% to 2.52% starting 2023. And we are really hoping that it gets approved by the new administration, thus setting the aspirational target of the RE to more than 50% by 2040. So that's one of the RPS. And Chester, what do you think about the other policies here in the Philippines?
Well, thank you, Ren. Well, in addition to that, we also have the GF, which is a new market development from the DOE to support in promoting renewable energy. I think they have awarded several companies for this. There are 5 in Luzon, 1 in Visayas, and 1 in Mindanao. But I think the major project was given to 1 company. The rate for that, I think it's 3.6 pesos. Although it's limited, or this is the phase 1 or round 1 for the GAP, I think moving forward, there will be another round. And aside from this, there would be, as you said, the RPS and the green energy option, which I think you can discuss a little bit later. But to comment on the utility scale market in the Philippines, I think it's improving and it's growing compared to other region in Southeast Asia. Like in Vietnam, they're not moving right now, and the market is not as big as before. While in Philippines, it's good because most of the big boys are moving ahead in developing solar. And in JA, we have supplied almost 0.5 gigawatt for the utility, including the CNI and the residential. So for those who have questions on the brochure data sheets, I see some of them are throwing questions. Please do send at sales@jsolar.com, and we'll be able to answer all of your questions. Going back to the utility scale market, I think, Ren, you can add a little bit more on the green energy option as one of the scheme from DOE.
Yeah, for the green energy option program, actually um, it's a support program from the DOE, which provide the end user the option to choose their RE resource as their main energy source. So imagine if GAP is, it's like a reverse of GAP. GAP is the one like applying for it, but for GEOP it's the end user requiring the energy from the provider to be RE, to be renewable energy. And as we all know, for the renewable energy market, I think right now solar is still the most cost efficient to build. That's why I think in the Philippines here in us, still even in the GAP bidding, I think out of the out of the 2 gigawatt that was bid out, majority is awarded to solar developers.
Yeah. So I wanted to ask, what do you think are the challenges in the market of Philippines for utility scale development?
I think you all know that. No, I think one is right now, of course, the since we are based on offshore supplies, the forex hits the per kilowatt price or per watt price of each development. So it's really a challenge for developers or EPCs right there to drive down the cost of this, especially the dollar peso ratio. The dollar is, I think right now as of yesterday 56 pesos. So I think that's one of the challenge. But on your side, as JA, what do you think is the other challenges for our market here in the Philippines?
I think the known challenge for us, and it is well informed to the utility scale developer in the Philippines, is that we are not able to hold and control the market price for our modules, and we have to strongly educate our clients that our industry has no discipline when it comes to pricing. So when the raw materials has low supply, or polysilicon increase its price, of course it will cascade to our modules, and thus the EPC offer also increases to the developer. But in JA Solar, we do help our clients think of a solution to be able to help them to manage the cost or the price that they're offering to the developer. For this, we can discuss further if you want to know more. But for now, we're trying to help our clients manage the price. Yeah.
Yeah. Thank you very much for your interesting insights. And I believe you have learned quite a lot, at least grab the whole idea of the market, how it grows, and the pros and cons, the strengths and challenges of the utility boom in the Philippines market. So I would like to change the subject slightly into a more, technical point of view. In recent years, we've been witness a boom of solar power, and not only in terms of demands, but also in terms of technology development. And since the demand for smaller scale solar projects go up, so does the trend for string inverters. And this trend has gone so far to change the whole industry actually. And string inverter now is not only applied in C&I and smaller scale solar project anymore, it also became a new favorite for utility scale worldwide. However, I know there's still barriers that stop investors from using this technology for their solar farm. And therefore, I would like to ask how the situation in the Philippines market, especially for the utility market in the Philippines. Are there a lot of solar farms using string inverters, or most of them still prefer central inverter at this moment? Hello, Mr. Rain, can you share a little bit on that?
Hi. Yes, Lizzie. So also on that note, for the string versus the central, I think uh, um, rec- um, previous years, I think there has been a debate which is better to use central or string inverter, and up until now. But for the Philippine market, the recent development I saw while I talked to EPC developers, and actually they, based on my experience, they are opening or leaning towards, at least for whom I talk to, they're leaning forwards to string inverters. The reason why is because you are string inverters had larger capacities than before. I think as you've shared earlier, GoodWe has 250 kilowatt already. That's a big technology improvement. Also, I think EPCs are happy with the improved energy generation loss. The mini the inverter route right now, or the string inverter technology right now, was able to minimize generation loss. And I think the developer's confidence uh, in avoiding on what they call a single point of error. A single point of error using, for example, you're using one central inverter, and if the facility or the power plant goes down, the whole generation goes down. And I think that's one of the thing the developer or the EPC wanted to avoid moving forward to the next phase of solar innovation, especially here in the Philippines.
Yes, thank you, Mr. Ren. Hello, Mr. Yuya. How's your view on this string vs central inverters for utility? Which way you leaning?
I think mostly I agree, Mr. Ren, because although the initial investment is higher compared to central inverters, for example, maybe on the investment stage you will pay more for string inverters, but overall you will see the string inverters still has its advantages. For example, we can see there's a 100 megawatt utility plant, and we use 400 pieces of 250K inverters, and then we use 32 pieces, 3.12 megawatts central inverters. So in the central inverters, they have fuses, combiners, so that we have to consider the fault rate there, and maybe that's above 5%. And once the failure happened, the scope of the failure is for string inverters is only 225 kilowatts, but for central inverters it has a much more impact. And for string inverters, the failure rate is really small right now. It's about only 0.4%, and there are 2% of failure rates for central inverters. And for the once the inverters failed, the repair time is also different, because for string inverters we can easily just replace them. It takes maybe a half day, but for central inverters it takes much longer. And with string inverters, since we have higher efficiency, we have about 1 to 3% per year of generation increase. So in this way, I think it has a better O&M and a better lifelong income. So I think that's why string inverters maybe have more advantages compared to central inverters.
Yes, thank you, Mr. Yuya. So even though the initial investment, it could be a little bit higher than a central inverter, but we can see that the total cost of the system throughout its lifelong years of, let's say, 25 years, it will be less cost for O&M, right?
Yes, you're right. Because you will bring more power generators later in the following years, and then that's bring you more money afterwards.
Yes, thank you, Mr. Yuya. And on the topic of hot trend and technology development, I would also like to point in the growth of especially the high power PV model recently. As we all can see, the market right now has a lot of type of high powered PV models, and the brands, they jumped into this array of new technologies that has changed the market so drastically that right now I know that there are a lot of consumers have a hard time to choose between this type of PV model vs another type. Let's say 182 vs 210, which one to choose and how to choose it. What is the pros and cons of each type? It could be quite complicated, and how to say, since the change happened very fast, it would be hard to some consumption. So I would like to invite Mr. John from GA Solar to help us view this matter from a more technical perspective, to help us to compare the many types of high power models in the market, the pros and cons, and maybe give us a advice on which technology to choose for each project. Hello, Mr. John.
Okay,
Hi,
hello, can you hear me now?
Yes, yes.
Yeah, as I just mentioned in my presentation, we have done much more thorough research, and throughout the whole years and energy yield data from the GoodWe and the Solar demonstration project, we find that the power generation performance of the 182 module is almost at the same level with the 116 module, but about 1.6% higher than that of the 210 millimeter module. I think this is mainly due to the difference of the operating current and the internal resistance loss of the module. Theoretically analysis, both 182 millimeter and 210 millimeter module are based on the same structure, like they use the half-cut P-type POC module, but they have the different operating currents due to different wafer size. And contributes by the lower operating current, the internal resistance loss of the 182 millimeter module is relatively lower. But for the larger current module, such as the 210 millimeter module, deal with the higher currents with the higher internal resistance loss, and this will lead to higher operating temperature, and this will decrease the power generation of the 210 millimeter module. So the energy yield performance of the 182 millimeter module is significantly better. Yeah, basically about this.
Yes, thank you, Mr. John. Okay, so I think we will move on to the next part, is the Q&A. And for this Q&A part, I think we will jazz things up a little bit, make it a little bit more excited. As I can see, some of the attendees here, they have raised their hands and they want to share some questions. So first of all, I will ask some of our speakers and representative from GA Solar to answer a question that has been sent by one of our registration. And the question is, as the PV industry leader, JA has offered a impressive Deep Blue series product for the next generation high density technology GFI. Could you give us more details? What are the technical highlights compared with other high density technologies? Hello, JA Solar. Can you help to answer this question first?
Yeah, hello, Lily. Yeah, I will answer this question on behalf of JA Solar. Yeah, as for, can you hear me now?
Yes, we can hear you.
Okay. As for the next generation high density module, we have our patented Lithium cell based on the N-type passivity contact technology. And for the module technology, we have the GFI. Yeah, GFI is a J patented high density encapsulation technology and integrated with flexible interconnection buffer treatment. And especially with the optimized encapsulation material, which could limit the cell microcrack problem issues. And compare it with other high density module technology, GFI has its unique features, such as GFI can both module efficiency and the module power. And also with the highest reliability, we could pass the 3 times IEC standard test and has the stable production stability and also compatible with both monofacial and bifacial module. Yeah, that's all my answer.
Yes, thank you, Mr. John. I hope the answer was clear enough for you to understand. If you have a further question on this matter, please send us an email and we'll share to the speakers. And I can see that one attendee has raised their hand to ask question. Hello, Miss Dan Carlo Ariola, are you there? Can you share us the questions you want to ask for the speakers?
Yes, ma'am. I would just like to ask for Antai.
Yes.
Are they using SAP 2000 for the structural analysis and design of their mounting structures?
Hi, Dan. Yeah, SAP 2000 is a software, right?
But are you also using STAAD Pro VATI or STAAD Pro Connect?
Actually, SAP 2000, I think we're using it. And the other one I saw with our technical team is the global software. That I think that's the two thing that we're using right now for structural analysis, especially for the wind load. For the others, I will check if we are doing it or if we're using it.
Thank you, sir.
Thank you.
Okay, thank you, Mr. Dan. For other guests, please raise your hands if you have any other questions, and you can directly communicate with the speakers here and now. So come on next to the next question I received earlier from the audience. There's one question about what should we pay attention to in PV plants on mountains. Can any of the representative here answer this question?
Can you repeat, Lizzie, the question?
Yes, the question is, what should we pay attention to when we install PV plants on mountains?
On mountains?
Yes, on mountain.
Well, for our concern as what do you call this, mounting supplier for us, I think that the soil condition is really important for us. So as much as possible, we do soil tests or geotechnical survey for that, so we can assess and what type of installation we can give for at least for the mounting structure on our side. I don't know with others if for GoodWe and JA you have considerations also.
Yes. Hello, hello, Mr. Daniel and Miss Chester from JA. Do you have any tips or advices for what to notice when install a PV plant on the mountains?
Daniel, do you want to answer the question or you want me to answer?
Well, so Chester, you can go first, and later I can give my opinion. Thank you.
Okay. So based on my discussion with the current installation with the owners or the developers, normally when it's hilly or it's not flat for utility scale, they prefer to use a smaller type of module. So when I say smaller, mostly we're using the 182 mm instead of the 210, because I think the main reason for them when it's on the mountain, they can squeeze smaller modules and then they can maximize the space for the installation. So I think for us, that's one of the consideration when you're choosing PV panels for utility scale installation on the mountain. So Daniel, would you like to add something?
Okay, thank you. Well, Lily, thanks for the question. And well, I think for mounting environment solar farm, first thing I think for the inverter, they will choose the string inverter because it's not flat. And the second is if the mounting is not like the ground, and for the hill, they may pay long time, and the hill will be more deeply, but it's very, very tough to do it. And second, you know, there's a typhoon. It's a bit common on Philippine market. So for mounting structure, I think maybe they should go with fixed mounting structure like Antai. They do this a bit well on. They doing well on the market. So for module, you know, the mounting, there will be some saddle or hill on the module. So they had better to choose the half zero. I think this is the market trend. Second thing is like Tesla says that it's better to choose a bit, I mean, the dimension should be a bit smaller one. That will be, how to say, avoid the shadow to happen on the solar farm. And meanwhile, maybe I can give you some other information about your last 2 or 3 questions. I think this is a very common question from the market, especially for Philippine market. And they may considering for the solar farm for the utility of solar farm, what's the inverter they should choose and what's the module they should choose. For the inverter, they may consider we should central inverter or string inverter. And for the module, like you ask, the module should 182 mm cell products is good or 210. And I can tell you the figures from the market is that the string inverters shipment on the world going up sharply in last 5 years, even 7 or 8 years. And for 182 mm, I think for the advantage of technology, our technical manager, Mr. John, he already gave very clearly details. And from my side, I may share some information from marketing. And for Philippine market, I think this year totally will be around 1.2 or 1.5 gigawatt. And for JA Solar, we already closed the contract more than 600 megawatt. And we already ship out around 150 megawatt to the market. So this is a very good proof about the advantage of 182 products. And also, like I said, that for Philippine market, almost the products is string inverter. And it's also the trend. Thanks.
Yes, thank you, Mr. Daniel. Thank you, Ms. Chester, for your great answer. And I have seen a very interesting question from the audience today. They asked about a supply chains and logistic risk. And the question is, due to supply chain and logistic risk, how can we manage the volatility of cost of the set equipment? And as I understand that many of the EPC and investor in the utility, they quite worry about how they can make the biggest save from their orders for the equipment in the time of such a harsh of the supply chain, when we see the shortage of materials everywhere, and also some logistic risk can happen and can delay the delivery. And how can they manage this, or maybe how can they save a little bit of cost on this aspect? Maybe can the speakers here share a little bit on their experience?
Oh, well, so maybe I can go first.
Yes.
Thank you. I think this question is almost the investor or EPC they are considering. And well, I think the first thing is the choice. To make the right choice, this is the best service for them, and also best ROI for them. So like the string inverter or and the suitable modules. So this is very important for them, because the product's warranty or the solar farm is around 25 years or even more longer than that. So the right choice is very important. Second is, I think, how to say, those years is very crazy on the market in the last 3 years. The price is really keep going up. And the silicon and the glass or exchange, everything going up. I think this is the whole world environment. But what we can do? We can do is that we should do our action on the right time to set how to say to finish the communication with the right supplier on time to catch the time window. And meanwhile, I may share the marketing trend in the future, especially for the cost. So in coming 1 year, in coming half year, let us say, because most of Philippine project, the COD time is around end of this year or mid of next year or end of next year. So in coming half or 1 year, the raw material cost will keep in higher level. So depending on the COD time, I think if everything, every condition already ready, I suggest all of the suppliers or investors, they should close everything and sign the contract a bit earlier. That will be helpful for them. That's all.
Yes, thank you, Mr. Daniel. Hi, Mr. Ren, do you have any?
Can I add on that, Mr. Actually,
Yes.
Mr. Daniel is right. Just want to emphasize that because last year we experienced that shortage in the PV panel industry around Q4 of last year. No one can deliver unless the price you bump up the price per kilowatt or per watt of the module, because by that time last year I was still in a panel manufacturer. I guess I can agree with Mr. Daniel that when the price is already acceptable to you or to the developer or to the EPC, I think it's the right time to book or to sign the contract. Don't wait for the price to. Many of us are still, especially the developers or EPCs. Many of us says, "Oh, maybe next month the price will go down. Maybe next month the price will go down." But if the price by this time is already okay with you, with your cash flow, with your ROI and everything, I agree with what Mr. Daniel says. Sign the contract, plan the timeline of deliveries already to avoid this kind of uncertainties and volatility in the market. Because in the long run, it will affect your development. Everyone has a COD date, right? So if you are an EPC, you also have a LD or liquidated damages to the developers. So if you keep on waiting and you have a poor planning, I think it will cost you more than waiting for a lower price.
Yes,
So,
yes. Okay, thank you, Mr. Ren. And from GoodWe, hello, Mr. Leo. Do you have any ideas on this matter?
Hey, hello. So, yeah, like you know, now the material for the solar inverter is also, how to say, is also quite challenged. And as a top one leading manufacturer for solar inverter, currently our production capacity and our lead time is allowed, small capacity is allowed 1 month, and then we can satisfy. And for utility models like 225 and 250 kilowatt, and we try to achieve within 2 months. And for the 80 kilowatt to 136 kilowatt, it takes a little bit longer, and it allows 3 months. So this is the current situation about about our lead times.
Yes.
Yeah, and here, how to say, yeah. Yeah, here I also see some audience that they are wondering where to buy, how to buy. Yeah, as a, how to say, as a new brand, and we are also welcoming some big partners there to better serve the market, to better develop the market.
Okay. Okay. Thank you, Victorio. Thank you, everyone, for your brilliant answers on these matters. And so for sum up, we all would like to just share with you one message that in this time of uncertainties of the cost of the materials, it's best that you all plan ahead what you want, when you want it, and then make the order in advance. That would be the best way to deal with all the costs rising up or even delay in delivery, and then you won't have to worry a little bit too much about it, because if you wait for the cost to come down right now, it could be, let's just say, it's almost impossible and we cannot predict anything right now. And thank you everyone for joining our webinar today. The time is actually up, and I know that we say that we will have one lucky draw, but because the time is not much here, so so we will send the gift to the lucky winner of today. And the lucky winner will be amongst the attendees that actually join our webinars today only. We will have around 12 Amazon gift cards of $50 each. And it could be quite a substantial amount for people in need. So we will send the gifts to you via email. And for those who have questions here that haven't been answered yet, we will answer every one of you via emails. And the webinar is recorded, and all the material will be sent to you after this event. Thank you so much for spending time with us. Thank you, the speakers, for sharing your valuable ideas and insight. We're very happy to host you all here, and wish you all have a good day. Thank you.